So now we are going to discuss about the continuous memory allocation. So the main memory, where we are going to store our operating system and the program which we are going to run. So the operating system will be stored in a higher order or lower order of the memory. So the remaining part of the main memory will be utilized to store the user program. So depends on the size of the program, the partition will be made. So that is called as variable size partitioning. For example, this first uh, the OS has been stored in the higher memory, for example. So it will be stored in the high memory address. So this is the low memory. Okay, now the process 5 comes, so it occupies some space. Then process 8, the size of the process 8 is high then compared to a processor. So depends on the process size, the partition has been made at first. Now the process 5 completed, the process 8 complete its execution. The free memory now that is called as whole. So now the process 9 comes, so it occupies the free space, but the process can be occupied in the continuous memory location. The address should be continuous. Now the process 5 complete its execution. So there are two memory spaces, the above and below. There are two holes are there. So this is the continuous memory location. Now you consider how while the new process comes into the main memory, how we are going to fit that, how we are going to choose in which partition the process need to be stored. There are three techniques. The first one is the first fit. In the first fit, we need to allocate the first hole that is big enough. So in first fit, we need to allocate the first hole that is big enough, that is large enough, that need to be allocated. So the searching can be start either at the beginning of the set of the hole or at the location where the previous search has been entered. So this is the first bit. The best fit. So allocate the smallest hole that is big enough for the processor. So here we need to allocate the smallest hole, but that hole should be big enough for that process. That is big enough for that process. So here, um, you need to find that smallest hole that is big enough for the process. The entire memory need to be searched. So what are all the free spaces, free holes are there, everything need to be analyzed. Then only we need to allocate the smallest hole. Unless otherwise, the holes are ordered by its size. So then the worst fit, here we need to allocate the largest hole, whatever the hole which is available. So in that the largest one we need to allocate the largest hole. For this also we need to search the entire list unless it is sorted by size. If it has been already sorted by size, there is no need to search. So the last one, if it is ascending order, the last one will be the largest hole. So that should be allocated. So it's the largest hole. Okay. So here the problem is fragmentation. So consider the example here. There are now there is a process. Consider this one. Now there is a process 10 comes. We need to store that into a memory location. For example, here we have a 5 KB of free memory. Here we have a 10 KB of free memory. The process the 10 needs 15 KB, but the 15 KB is available freely available. Free space is available in the main memory, but it is not contiguous. That is called as external fragmentation. Okay, so the enough memory space is available. So that is external fragmentation. Enough memory space is available. Enough free space is available, but it is not continuous. But not so that is external fragmentation. The solution to the external fragmentation is called as compaction. So here we need to shuffle the memory con- shuffle the memory content so as to place to all the free memory together in one large block. So we need to make all the free memory together to make it a one large whole. So then whatever the process comes, if the memory space is available, free space is available, it can be occupied. So next one, the internal fragmentation. Here in the internal fragmentation, the memory allocated to a process may be slightly larger than the requested memory. So the difference between the two numbers is called as internal fragmentation. So the memory allocated to a process is little bit higher. The memory allocated is higher than the size of the process. So in internal fragmentation, the memory the memory allocated to a process may be slightly large, slightly larger than requested. So the difference is called as internal fragmentation. So I repeat again. So in a continuous memory allocation, the memory for a process should be allocated continuously. Okay. So while here there is a how we need to allocate that process in the particular variable size memory location. There are three techniques. One is the first fit, best fit, and worst fit. In first fit, the first hole that is large enough to occupy that process, that is first bit. In this best fit, smallest hole that is big enough to the process. The worst fit, allocate the largest hole in the available free list. So here there is two problem fragmentation issue. One is the external fragmentation. Enough space is available, but that is not continuous. So to avoid that external fragmentation, the solution is compaction. So you need to put all the free memory together to make a large whole. That is compaction. The internal fragmentation is the memory allocated to a process might be slightly larger than the requested. So that difference. So it makes that hole in the internal partition inside that internal partition that is called as internal fragmentation. Thank you.